All right, you ready for this? We're going to do another system with a quadratic and a linear equation. Now, first off, I want you to remember this is nothing different from doing linear systems. It's exactly the same as what we've been doing, except this time you got a quadratic involved. Okay, the process is the same. So we're going to do the same thing as we did in the last video. I'm going to do substitution first because that's what most of you like. And first I'm going to make sure I can spell substitution correct while I'm talking, because when my mouth moves, my brain stops. So here we go. We're going to solve by substitution. The first thing we got to do is isolate a variable. Oh, Mr. Bywater, I got y all by itself. Very good, Mr. Bywater. So y is all by itself. You don't have to do any more work for isolating the variable. Once you isolate the variable, you just take that and you put it into the other equation, which is going to work out pretty nicely. So I'm going to take the negative 2x plus 5, substitute it for the y, because that's what y is. And so I'm going to have negative 2x plus 5 equals x squared minus x plus 3. And remember, the next thing that we did with substitution is that we then solve for the variable. Well, I note here that I've got an x squared. When I've got an x squared, the best way to solve is either by quadratic equation or the quadratic formula. All right, so I can go ahead and add 2x and subtract 5, and add 2x and then subtract 5, and then I got 0 equals x squared. I got to have it equal to 0. Both factoring and quadratic formula require it to be equal to 0, and so that's my first priority when I recognize it as being quadratic. Remember, with linears, you're going to isolate the variable, but with the quadratic, the best way to do it is get it equal to 0. I'm going to end up with plus x and then minus 2. Now, if I wanted, I could solve that by quadratic formula, because I know that x equals negative b plus or minus square root b squared minus 4ac all over 2a. But I'm not going to do that because I really don't like the quadratic formula. I just like singing the quadratic formula. What I'm going to do is I'm going to factor, because factoring is faster and easier when it works. Mr. Rahman will tell you that factoring is stupid because it doesn't always work with the quadratic formula. It does. But you know what? I'm going to tell you that I like factoring because it's easier sometimes. So I'm going to go ahead and factor. This is definitely a trinomial. So I got x and x. It's a minus, which means that the signs have to be plus and minus. Now 2 is 2 times 1. I know that I want the 2 to be positive because I want the bigger number to be positive. So I'm going to put the 2 and the 1 down just to check. X times negative 1 would be negative 1x. 2 times x would be plus 2x. Those would come together to give me just an x. So I factored it correctly. And I know that when I factor it, if two things multiply together to give me 0, then one of those two things, either the x plus 2 or the x minus 1, has to equal to 0. And either one of those can be equal to 0, but it doesn't matter which one. One of them has to be 0. And so I get my two answers, x equals negative 2 and x equals 1. And then I'm done. Nope, one and done rhyme, but no, I am not done. Why am I not done? Well, because all I have is the x values. Remember, in substitution, you isolate the variable, substitute, solve for the variable. Once you have the x value, what do? You take it and you put it back into the original equation to find out what y is. Remember, we are finding the intersection points of these two lines, this quadratic, which is a parabola, and this linear graph. We need to find out where they cross. So in order to do that, I need an x value and a y value. Right now, all I got is two x values, which means I'm probably going to have two intersection points. All right, just like in the last video. So what we're going to do now is we're going to take that x value, just like we did with linears, and we're going to put it back in. You can put it in either equation, doesn't matter. I like to use the linear one because it's easier. So I'm going to put negative 2 in for x, so negative 2 times negative 2 plus 5. And then I get y equals 4 plus 5, and so y equals 9. All right, so I got one of them right there. And then here, that means when x is negative 2, y is 9. All right, and then I'm going to put x equals 1 in. So I got to do both of them. Y equals negative 2 times 1 plus 5. So y equals negative 2 plus 5. So y equals 3, which means when x is 1, y is 3. And there you go. Those are the two intersection points. If I wanted to check, and you should on your homework, You can put negative 2, 9 into both equations, make sure that it works, you're good to go. You can also put 1, 3 in and check to make sure that one works. They're both solutions. You better check both of them in both equations. All right, we're good. I'm going to go ahead and write those down. Negative 2, 9 and 1, 3, because I want you to compare that to what we get when we do graphing. So I'm going to go, because when I go, everything disappears, except for maybe a couple of things that I missed. And now we're ready to go do graphing. Our favorite. Graphing is easier to spell. Even when I'm talking, I can spell graphing even if I'm not thinking. So let's go ahead and graph. You know what? I'm going to go ahead and start with the linear equation first because it's already ready to go and that's easy. So I'm going to go ahead and do my y-intercept. This is just simply y equals mx plus b. Y-intercept is 5. So put my y-intercept down. And then I got my slope, which is negative 2. So I go down 2 to the right 1. Down to right 1. Notice that if I have a negative slope, if I go from left to right, it's going down. Okay, so left to right, going down. I'm going to put as many points as I can because I found that the more points that I put, the better my results are in the end and the better that my line looks. I am in no way, shape, or form a great artist, but I am really good at graphing lines because I put lots of points down. All right, so there we go. We got a straight line there, which is representing our negative 2x plus 5. All right, I'm going to go on to the quadratic now. So now I'm going to shut the linear graph out of my mind. I'm not going to think about it anymore. It doesn't matter. All I'm worried about now is my quadratic. How do I graph quadratic? Well, first thing I do is I find the axis of symmetry, of course. Axis of symmetry happens at negative b, x equals negative b over 2a. B, of course, in this situation is the number in front of the x. So that's negative 1. All over 2 times a, which a is the number in front of the x squared. Remember, this is ax squared plus bx plus c. So b is the number in front of the x, a is the number in front of the x squared. Got it? And I get 1/2. Oh, there must be something wrong. It's a fraction. Nope, sorry. Fractions are life. Deal with it. I can sleep well at night knowing that I just gave you a fraction and have absolutely no problem with that. So deal with it. So we just got a fraction right here. The fraction gives us 1/2 is half of the way between 0 and 1. Okay, that's just the way it is. So I put it in between 0 and 1. There's my axis of symmetry. Now it would be really nice if I had the vertex, which is somewhere on that axis of symmetry. Well, x equals 1/2, so if I put that into the equation, then it shouldn't be a problem to get the y value. So I'm going to put it back in. Make sure you put it back into the quadratic. Don't put it into the linear. The linear does not have a vertex. You cannot put that 1/2 in there and hope to get the vertex because that will give you a point on the linear graph, which is not the vertex in 99.9% of the situations you may ever face. So we're going to go back into our original equation. Y equals x squared minus x plus 3. And I'm okay with you punching that into a calculator if you want. I know 1/2 squared is 1/4 because 1/2 times 1/2 or half of a half is a quarter. And then I can subtract 1/4 minus 1/2, which is negative 1/4 plus 3, which ends up giving me a total of 2 3/4 or 2.75, which I can put on my graph. 2.75. So somewhere around there, and this is not going to like me, but there we go. It's right there, somewhere around right there. Okay, so I've got my vertex. Done! 1/2, 2 3/4. All right, axis symmetry done. Now, the next thing that I would usually look for if this were me would probably be the x-intercepts, but I got a secret. There are no x-intercepts. But Mr. Bauer, how you know there's no x-intercepts? You only got 1 point on there. I'll tell you how I know, Mr. Bauer. Because this x squared is positive. And you'll remember back from when we did transformations, if it's a positive x squared, it's got a U shape, like this. A negative x squared would be then flipped upside down. But this is a positive x squared, so it's a U shape. The vertex is at the bottom then, which is right here, which means it has to be going like this. There's no way that's ever going to get down to the x-axis. There are not x-intercepts. Now, just to prove it, I am going to use the discriminant. Hopefully you remember discriminant, the b squared minus 4ac. That's the stuff under the square root in the quadratic formula. So b is -1, so -1 squared minus 4 times a, which was 1, times c, which is 3, and that'll be 1 minus 12. 4 times 1 is 4 times 3 is 12, which gives me a -11. And remember, when I get a -11, that means that there are no solutions or that you can't solve that specific quadratic formula. Now, that doesn't mean that the graph doesn't exist. I'm trying to solve here for the x-intercepts when y equals 0, and so therefore that negative intercept, that -11, means that this is not possible, that there are no x-intercepts. It doesn't mean that the graph doesn't exist. There's a quadratic there. I can put numbers in for x. I can get numbers out for y. So don't you dare tell me that there ain't no graph there. There is a quadratic graph. We just have to dig a little bit further. Dig a little deeper. I don't know where that came from. Anyway, so what we're going to do to get a little bit more is we're going to go ahead and get the y-intercept. All right. So the y-intercept is when x equals 0. So we're going to go y equals 0 squared minus 0 plus 3. And so I get y equals 3 will then be my y-intercept. So I'm going to go ahead and put that on there. That I can reflect to the other side. And oh, look at that. It was right on top of that red point right there. You see that? So I got one of the answers already. But, you know, I've just got a couple. I got 3 points for my quadratic graph. Yeah, it's kind of fitting what I expect it to look like, some kind of quadratic parabola there. But I'd really like another point or two. All right, especially since I only got 3. And Bdubs once told me I had to have 5 points. 5 points, can you believe that? 5 points? Yes, 5 points. So we need 2 more points. So in order to get those 2 points, we're going to need to we've got all our special points here. What we're going to have to do is just put in an x value and get a y value out. Now, hopefully you're going to say, okay, well, I could put in any value I want, and that's absolutely fine. But let's be a little bit smart about it. Our graph's going to look something like this, right? So I don't really expect, there aren't going to be any more intersections over here. It's probably going to be over here as this graph gets steeper and steeper. Now my guess is that it's going to happen somewhere around here, right? You can kind of see your graph going up. And so probably -2 or -3. I'm going to guess more likely -2. So I'm going to choose -2 to be the x value that I put in. Okay, now you can really choose any value, but it may force you to estimate the actual location of your intersection. So just be careful with it, all right? So we put -2 in. Again, I'm still working with the quadratic. So it'll be -2 squared minus -2 plus 3. You'll notice that that will give me -2 squared, which is 4, minus -2, which is plus 2, and then plus 3. 4 plus 2 is 6, plus 3 is 9. So therefore, when x is -2, y is 9. And I can go 1, 2, up to 9. Oh, look at that. It's right there on top of that red line. You see that? That's pretty. Yeah, that's pretty. And then, of course, I can reflect it over 1, 2, and 2.5 spaces away. So 1, 2.5 spaces away. I'll put my other point there. I can go ahead and draw my quadratic graph. Now, please do draw it on. Don't just say, oh, I got my points. That's all that matters. Sometimes that's all that matters. Sometimes I really just want to see your nice quadratic graph there. Like I say, I'm not an artist, but I can draw graphs because I put enough points down. So I got my points there. I now have my answers, which are the intersections. Note that it intersected right there at 1, 2, 9. So -2, 9. And right here at 1, 3. And note that that is exactly the same answers we got from substitution. Just 2 ways of doing the same thing, but yes, you need to know both of them because there are different ideas associated with them that we want you to know. We want you to be able to see the visual. We also want you to be able to do the substitution because that works with almost any kind of function that you could even come up with. All right, so there you go, and why don't you go try another one because I'm going to do another one.